Let's see how a jewelry thief circuit works. In this video, I'll show how a Joule thief circuit works, and it's working. Yep, with circuit diagram. To make a Joule thief circuit, the main component here is an inductor specially made for Joule thief circuit. Here I have chosen 12 cm for both thick and thin wire, or high and low gauge wire. They both should be the same length. I'm using an NPN transistor D882. You can use a different NPN transistor also, which is this one right here, which is N428. Instead of a fixed resistance, I'm using a 10 kilo ohm variable resistor. This is because I can set in the right resistance where the LEDs are really bright, so that I'll know which point is the perfect resistance to use. And you'll require some LEDs. I'm using 2 LED. My circuit can turn on 2 of them. 3 LEDs in parallel as a load. Let's see if this turns on with just 1.2 volt. And all the 3 LEDs glow bright.
Give me some money!
Please understand how this circuit works. This Joule thief circuit works. Here the positive is connected to low gauge wire winding and also high gauge wire winding. When the voltage is applied, the base gets current, and when the base gets current, it allows the electrons to flow from emitter to collector, so it flows in this direction. Now here not only the LED is getting the current. You see this? This is also connected to the thin winding or high gauge winding. Even this coil turns on now. When this coil turns on, this produces magnetic field, and this magnetic field is induced just like that. And also the low gauge wire or the thick wire also induces, but it's very less, so they repel and it gets cancelled. Now as I said, the magnetic field induces and it influences the electrons in the low gauge wire to make the electrons flow even more. When more electrons flow to the base, that means the gate opens even wide, or more electrons can flow from the emitter and collector. So this keeps happening, and more magnetic field keeps inducing, and it reaches a point where it is called saturation point, where the magnetic field can no longer be increased. When there is no way that the magnetic field can be increased, it all goes down. That means the process reverse. The magnetic field starts to decrease, the base current gets less voltage or current, and everything turns off. Now this process happens really quick. When this process happens really quick, the charge in this inductor rapidly charges and discharges. When an inductor discharges, it generates more volt than the source itself. That means if the source is 0.8 or 1.8 volt, then the output volt will be more. All this process is happening really quick. that means the LED is rapidly turning off and on. It's not really on, but our naked eyes can't see that. Thanks for watching.
Who made that mess?
If you like this video, please subscribe and like. I hope you enjoyed.